Hi everyone. If you recall last week we were working on relations, and in a relation we found out some key terms that we were discussing. We talked about input and outputs, domains and ranges, and we talked about these x and y values. So today we're going to take it one step further, and we're going to see that sometimes a relation is a function, and then we're going to find values for functions. Well, a function is a relationship between that input and output, and it states that there's exactly one output for each input. So every input can only have one output. Let's explore this a little bit. So if a function is a relation in which every element in that domain, which is our input, is paired with exactly one element in the range, which is our output, we can go back and use what we learned about relations: mapping, a table of values, ordered pairs, graphs, and even equations can be used to determine if a relation represents a function. Let's take a look at a couple. Function or not a function? That's the question. Does every input value or every domain value, again this is my input or my domain, and then my output is called my range. Does every input value have exactly one output value? Well, again, we talked last time about writing them as ordered pairs as well, and I'm recognizing in mapping it's telling me that -2 is paired with 3, 0 is, with 5, 0 is paired with 3, 3 is paired with 2, and 4 is paired with 1. So that's my first relation. Is it a function? Yes. Every input value only goes to one output. Let's look at a second example. And again, this first representation is my domain. The second is my range. If I write this out, I see that -2 is paired with -3. -1 is paired with 6. 0 is paired with 6. And 3 is paired with 9. I look at the -2, the -1, the 0, and the 3, which are my inputs or my domain, and they only have one output. They're not repeated. If they're repeated, then they must go to the same output. So far again, these both represent functions. I can also use a table of values to represent a possible relation as a function. Once again, I can write these as ordered pairs, but I notice that 1 is paired with 4, domain to range. My 3 is paired with 2. 5 is paired with 4. 1 is paired with -2. And 7 is paired with 4. Now here's what I want you to focus on. The domain or input value of 1 is repeated. In order to be a function, it has to have the same range value, and it doesn't. So this does not represent a function. So this is not a function. Once you notice that the input value is repeated at all, it must have the same corresponding output. Let's look at one more. Sometimes I like to write them as the ordered pairs. I see that 8 goes to 6, 6 goes to 4, 4 goes to 2, 2 goes to 0, and 0 goes to -2. None of the domain values are repeated. They all go to one output. This is a function. Once you start to recognize a few examples, it becomes much easier to recognize. Let's just take a look at one more before we move on to the next part of the lesson. 5 goes to 15, 6 goes to 15, 7 goes to 15, 8 goes to 15, and 9 is paired with 15. This represents a function. Why? Every input value has only one output. I'm not repeating the 5, the 6, the 7, the 8, or the 9. It's okay for different inputs to have the same output, but it's not okay for an input to have different outputs. Okay. Again, the understanding with that comes with a little bit of practice. So let's determine whether the following ordered pairs represent a function. I did it in mapping, I did it in a table. Now let's look at it with the ordered pairs. When you're looking at the ordered pairs, in the beginning when I'm just learning this or teaching this, I underline those x values or the input values, and I look to see if they're repeated. If they're not repeated, then this is a function. Hopefully you'll start to see it a little more clearly now. Let's take a look at another. I'm going to underline my x values. Wait a second, I see that 4 is repeated. Now 4 is repeated, and in this one it goes to 8, and this one it's paired with 14. This is not a function. Every input can only have one output. Let's keep going. I have it 2 is my input, 3, 2, and 5. 2 is repeated. In this one it goes to 7, and this one it goes to 7. This is a function. It has the same output in both of those ordered pairs. I have 2 goes to 3. Well, these are all 2's, but I see that goes to 3, goes to 4, goes to 5, goes to 6, not a function. An input cannot have different outputs. It's a relation, but just not a function. And we have one more here. 3 goes to 5, 4 is paired with 5, 5 is paired with 5, and 6 is paired with 5. I have 3, 4, 5, and 6 as my inputs. Nothing's repeated. This is a function. So I hope you're starting to see the connection between the input and the output terms. There's one other thing we can do, and this is the visual. It's now on a graph. It's called the vertical line test. If I were to graph some points and it created this straight line, this is a linear function. You could take a line, and let's just see if I can sort of create this a little bit. And if I were to take this line, I don't know if I'll be able to, but I'm going to try. If I were to take this line and sort of move it along the coordinate plane, you'll notice that there are no 2 points in the same vertical line, meaning up and down. However, in my second graph, let's just suppose in my second graph that after graphing some points, I had something that looked like this. Oops. Let me get my pen ready again. And if I graphed all these points, now if I were to take this straight line, this vertical line test, you're going to notice that there are 2 points in this same vertical line. I could continue, and there are 2 points in this same vertical line. Same would be here. So across the line here, there are 2 points of the same vertical line. Let's just look at the coordinates of these 2 points. 1, 2, 3, 4, 5. This one is 0, 5. And this one is 1, 2, 3, negative 4. Well, the input value is the same, but the outputs are different. It's not a function. You might be asked to look at some graphs and determine if they're a function or not. If you had a function and it graphed like this, once again, you're checking to see if there are lines, 2 points in that same vertical line. This is a function. No 2 points in the same line. And then if I had something like, let's see if we could just put one more up there just to see what it looks like. If I had a graph of a line that sort of and again, I have points in the same vertical line. Points in the same vertical line tells me that this is not a function. Okay, function or not a function. In our next lesson, we're going to look at finding values. I'm going to stop the lesson here, and in the next one, we're going to decide whether we can determine values by inputting, and we could do it in the table form, but we're going to learn something called function notation. So that's a little something for next class. Until then.